Alright, hi everyone. We are graphing sine functions today. We have sine and cosines, but we're going to specifically stick with sine functions. So graphing sine functions. Alright, so this is demonstrated by, let's start off with our very basic one, and we're going to say f of x, which can be considered y, right, is equal to sine of x. And when we look at sine of x, this is really a ratio of opposite versus hypotenuse, and we can always see this in a unit circle as the y value in our unit circle. So I'm going to go ahead and create a table x and y here, and then we are going to draw a unit circle. And I'm going to draw a couple points that are important here as 0 degrees, pi over 2, pi, 3 pi over 2, and back to 2 pi. 0 pi over 2, pi, 3 pi over 2, and back to 2 pi. And then I'm going to give you guys the point here on the unit circle, which is 1 comma 0, because it's 1 space x, y space is 0. And on top here, we have our 0 comma 1, x is 0, y is 1, because we went straight up. Remember, this is 1 unit, so radius of 1. On the left side is negative 1 comma 0. And down here it's going to be 0 comma negative 1. And then we go back to 1 comma 0. And the circle just keeps going round and round and round. Now just as a reminder that the sine value for the unit circle, remember this, the x is my cosine value and your y value is your sine value. So this is going to help us, without a calculator, come up with our sine values very quickly. Now one thing we have to take note is that when I am graphing in of sine of x, it is always 99.9% is using radians. X is in radians. As you can tell by my unit circle, we use 0, pi over 2, pi, 3 pi over 2, and 2 pi. These are all in radians. We're not going to use degrees for the most part. We can use degrees if you want, but this picture would be a little different, okay? And if you use the wrong value in your calculator, of course, it's going to be wrong. You guys can take out a scientific calculator if you want right now, and we can get the same answers on your scientific calculator as we do from the graph on your right. So we're going to plug in our value 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now if we were in class, I would actually do all the ones in between. I would do 30 degrees, 45 degrees, 60 degrees, and then 150, so 150, that's not 150. 120, 150, and then 180, and I would just go all the way around, and we'd have like 17 points to worry about. But since we're not in class, we're just going to worry about the main easiest ones: 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this is going to illustrate, just like when we first started learning in algebra how to graph a line, we just plugged in values and see where that took us. So we're just going to do that. We're going to say sine of 0, because x is 0. This is my f of x, right? What is the sine of 0? So if you have a calculator, you can write sine of 0 on your calculator, or you could look at my dot here, and the y value is 0. Another way of looking at this is, what is the y value of the unit circle at 0 degrees? The y value is 0 degrees because you're sitting on the floor. What is the y value of your unit circle at pi over 2? Going straight up, what's the y value? Looking there, that is 1. All right. So far, don't graph this, but take a look here. We're always going to write 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is our basic parent function. And we said when sine is 0, we're going to graph a 0. And when sine is pi over 2, see this pi over 2, we're going to graph a positive 1. So does this graph look like it's going to take off at a line? And that's the question. Just you have 2 points. Are we done? But then if I look at pi, think of the circle. The y value starts to increase, and then it starts to decrease again after pi over 2. So after pi over 2, if I stick sine of pi on your calculator, if you guys want, you guys plug in sine of pi, and you get an interesting answer. You go back to 0, because the y value is back to 0. Okay, that's like the height of your circle, you could say. It really smells like my house is burning down. Okay, so back to 0. So we have our points here. Let me use a different color here just so you guys can see that. 0, up, 0. Our next value here is sine of 3 pi over 2. Maybe you guys can go ahead and take a look at my unit circle and make a nice guess what that would be. What would the y value be there?
-1.
-1, thank you. That's exactly what it is. And we're going to graph -1 here. Here's -1-ish, right? -1. And then we're going to hop right back into it and put our last one. Sine of 2 pi. Completing the circle. Circle of. And we end up with the y value back at 2 pi is 0. Now we have all these points here on the graph now. If we had more points, this would look like a nicer, smoother graph. But so far, you think it's going to look like the ancient pyramids or something. And please don't draw that because that's wrong. We're going to draw this as a curve, like throwing a ball up in the air. When you throw up a ball up in the air, it goes high and then slows down and comes back down. Okay? So whenever I draw these, I actually draw these in actually 4 steps. I go curve up like I'm throwing a ball, and I actually take my pencil off. See, it's off. And then I fall back down like I'm throwing a ball. Then I dig a hole, and then I let go and I dig myself out. Give yourself a little arrows at the end because this graph does not stop. It keeps on going. And it actually turns out to repeat this pattern over and over and over to infinity. Why? Because the circle goes 1, 0, -1, 0, back to 1, 0, -1, 0, back to 1, 0, -1, 0, back to 1. Remember how we said these are coterminal? Because the values just keep on going repeatedly. It's a freaking circle, folks. So this would just keep going in the same pattern to the end of the universe. And that is a sine graph. We also term this as sinusoidal. I think that's how you spell it. I'm terrible at spelling. Sinusoidal.
Down a little bit.
Huh? Sinusoidal, meaning this graph, it has this pattern of a sine graph. So whenever you see anything in electronics when they're measuring what they call a sine wave, it's sinusoidal. So if you hear the word sinusoidal, it means it's just going to go up and down, up and down, up and down, like the waves of the ocean. They don't call this cosinusoidal, okay? It's just basically, it's a sine graph repeated, okay? So that's great. Now, will I have to do this for every single freaking problem? And hopefully you realize in math now, we don't do that. What I mean is that we look for characteristics and we graph characteristics rather than creating tables for everything. Tables are a great way to start. But once we start seeing relationships, we rather just graph those relationships. The example is when you guys learn in Algebra 1, when you learn y is equal to mx plus b. Did you start creating tables for every single problem? Or did you just say, that's my slope, and that's my y-intercept? Y equals to 1/2 x plus 2. You don't plug in 0, plug in 1, plug in 2. You just say y-intercept is 2, put a dot, and climb the slope. Rise 1 over run 2. Right? As we learn different types of graphs, we find patterns to graph them faster. In Algebra 2, we looked at parabolas, and we said y is equal to a x minus h squared plus k in vertex form. Y is equal to, let's say if I say 2 x minus 1 squared minus 1. You said the vertex was 1 comma, whoops, not 0, 1 comma, -1, 1, -1. And then you said, hey, if it's a 2, 1 step over, 2 steps up, 1 step over, 2 steps up. And then you had your parabola in a matter of seconds. A matter of seconds. So we have characteristics of the graph, and we graph those characteristics rather than plugging values repeatedly over and over and over again. So we have a basic standard form for sine graphs, and that is going to be f of x, or you could call it y, is equal to a sine. Let me actually switch this different colors so you guys can see it stand out. A sine, and we write parentheses, b, whoops, that looks terrible, b x minus c. C, then plus D. If you see the letters in red, hopefully you're not colorblind like me, but we have letters A, B, C, and D. And each of these will apply to a characteristic of this graph. And it will change the characteristics of it. Now, let me go ahead and give you guys a brief overview since we're here already. A is going to be my amplitude. In a sense, how loud is this graph going to be? And this graph affects the height of the graph. Okay, it affects the height of the graph. Let's jump to the D. This is my vertical shift. And this affects the graph moving up or down. See, it moved the graph up or down. Our B value is actually two things. It's considered a frequency. Oh, that was terrible. Frequency. But more importantly, it's going to be our period. I'm going to put a star next to it. And that changes if my graph is going to be a regular graph, or will this graph be a super long graph or a super short graph. That looks a little bit weird, right? But it changes how long it takes me to finish the graph. It's almost like watching a movie at twice the speed, or watching it at regular speed, or watching it really slow-mo. Right? And this is our how fast it changes. And the last one here we have is our C value here. Oops, different color. And our C value here helps find, let's say this helps find phase shift. And phase shift is us moving in left and right. So I'm running out of space here. So this changes where the graph starts. So it moves it forward, and the graph now starts over here. See, it pushes the graph forward or back. So these four characteristics help you graph this graph instead of literally like 10 minutes, you can graph this graph in 30 seconds or less. Okay, maybe 40 seconds. Okay, you guys are a little bit slow. So we're going to talk about these characteristics. Today we're going to talk about A, B, and D. We are not going to talk about C. C is a lot harder, and when you move C, you move everyone. It's almost like going to the doctor's, and if the doctor is late on one appointment, he's late on all the appointments. They're all shifted over and everything's a big mess. So we'll wait until C till next time. But let's go ahead and deal with A, B, and D here today. So let's do the easiest one, amplitude. And the idea of amplitude, it's equal to the absolute value of A. We say absolute value because amplitude could go up or down, but generally our A value could be positive or negative. And this is some positive or negative number. Now let me go ahead and give you guys an example. Y is equal to 3 sine of x. Now you notice there's only an A value. So what I'm going to do, I'm going to have you guys always do this. Write down the letters A, B, C, and D. I want you guys to label what each of these are going to be. I'm going to write this on the side so you guys have their standard form, or if not, you can look at your notes. Y is equal to A sine of bx minus c plus d. So let's do the easy one. Do you guys see a d value here just floating around? No, so that's 0. No parentheses means no c. No parentheses means no c. The c has to be inside the parentheses. What is the b value? What is the value right invisible in front of the x value? An invisible 1, visible uno. And the number in front of my sign is the number 3. So the way we graph this, the way I teach graphing these, is that we start from the right and we work our way left. You guys ever go to Subway and you have to look for that sign that says start here, right? This idea, start here, start here, start at the end. So the D we said this is our vertical shift. So if there's no vertical shift, the vertical shift is at 0. So let's go ahead and start graphing it. I draw a little cross that's fallen over. And if D is 0, we are starting on the floor. This graph will be sitting on the floor. That means a little bit up, a little bit down, but all on the floor. First thing we want to take notice. C, there's no phase shift. That means we are going to start our graph right at 0, whatever that means. Okay, so two things. We already said this is D, and this is already C. We use 2 letters up already. B tells us our frequency or period. And that's going to lead us to an idea of the period is equal to this equation, 2 pi over b. Since b is 1 here, it's 2 pi over 1, which is 2 pi. Let me say this again. You will always calculate period using this formula here, 2 pi divided by b. So it's 2 pi divided by b, which is 1, so just put 1 there. So it takes me 2 pi to finish this graph. That means I only see this as one circle, and it takes 2 pi to finish this one circle. 2 pi to finish this one circle. Now, the b is when I start to draw this. I draw a tick mark at the end. And let me say this, that's my 2 pi. How long did it take me to finish the graph? We said 2 pi. Draw a line at the very end and write 2 pi yourself. If you want to draw here, fine, draw here, write 2 pi. I don't care. Just write it someplace. And then we're going to create tick marks here so we don't squish the graph. We want to make sure we pace out the graph. And what I mean is we're going to give ourselves gates to cross. We're going to have 4 gates to cross. So to make sure they're even, I always have kids do this. Starting at 0, ending at 2 pi, and we're going to make some tick marks along the way. And the tick marks follow this simple rhyme, which is not really a rhyme. It's half, half, and half. It's half, half of that, and half of the other half. Half, 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 half. Okay? When I do this, it gives me 4 gates. 1, 2, 3, 4. If you guys ever heard of people running a marathon, there's always gates that they cross to keep their pace. And also to tell them, hey, you're on the right track. It helps them keep their time. You are 1/4 through the race. You are halfway through the race. You are 3/4. You have 26 miles to go. And now we're going to label the gates. What is half of 2 pi? Half of $2 is $1. What's half of pi? Half of $1 is 50 cents. I'm going to write pi over 2. Please do not be afraid of writing pi over 2. Now what's this gate here going to be? You could say 1 plus 2 is 3, and half that, that's the average. But instead, let me show you guys the easy way of counting. If one block here is pi over 2, well, isn't this 2 pi over 2? And then this is 3 pi over 2? The trick is this. Figure out what your first gate is, and then just count 1, 2, 3 of that. So this is 3 pi over 2. Because if this is 1/2, well, that's 2, and now we're at 3/2. If this is 1/4, now 2/4, now 3/4. So you're going to have to label your graphs for credit.
Oh, Lord, I thought it was going to be pi over 2.
Well, not that bad. So again, let me repeat how I did that. I started at 0, and we went to 2 pi. And then we said, what's half of 2 pi? Well, that's just pi then. And half of that is pi over 2. And then we counted up, up, and up. That's 3 of those half pi's. So that's how we're going to do our tick marks. So we finished our C, our D, our C, our B, right? That gave us a nice spacing. Told us when to stop. And then we only have A left. And A is 3. So I'm going to count up 1, 2, 3. From the D value, I'm going to count my A value up and my A value down. 1, 2, 3. Because this is the amplitude of the graph. This is how high and how low my graph is going to be stretched. And I'm going to draw little dotted lines now. Anyone ever go bumper bowling? You guys know what bumper bowling is? Anyone know what bumper bowling is?
Never heard of it.
Never heard of it?
No.
If you guys have ever been bowling before, for little kids, they actually pull up the gates on the side, and then the kids never gutter. In some places, they'll actually blow up huge balloons on the side rails. Now you kind of know what I'm talking about, right? So fancy kids, right? You go have a kid party at the bowling alley, like any bowling alleys are left, okay? And then they pull up these gates, and then your ball just bounces between the gates, so everyone gets a strike. But there's always that unlucky kid that even though the gates are up, still strikes out.
I used to do it at a 40, make my siblings do it at a 45-degree angle.
Right, and if you throw it at an angle, go bam, 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 it bounces all the way down, and people look at you because you're making a lot of noise. And again, some bowling alleys, they just literally just blow up huge balloons that go all the way down the lane. Okay, so we created ourselves a bumper bowling, and look, our graph is gonna bump between these lanes, right? It's not gonna go, whoa, Mr. Co, hello, you have a bumper right there. You're gonna bounce back. So here's what we're gonna do. We're gonna now walk our way through these lanes. So sine starts at 0, and since it's positive, let me go ahead and you switch colors. I'm sorry. Looks terrible. Start at 0, please. Sine always starts at 0. When you sin, you feel like crap. Right? Sine of 0 is 0. And we're going to take one step up. Because remember, the circle goes this way, right? It doesn't go this way. So we go up, down, down, up. 0, up, 0, down, 0. 0, up, 0, down, 0. We're going to repeat that pattern over and over and over again. 0, up, 0, down all the way to your bumper, lazy person. And then back to 0. 0, up, 0, down, 0. And this is your graph. And again, when I graph it, I always do 1/4 at a time. I mark it and I bring up my pencil, come down, bring up my pencil, and then I switch orientations in my brain. And then so we end up with this nice ugly graph. I made that ugly. These are not straight lines, these are curves. Okay, and this is how we graph our sine graph with amplitude of 3. So how do you know the difference? So let me go ahead and graph the original one. This is a regular sine graph. So how do I know what has changed? So please look at my red graph versus my blue graph. Does my red graph and blue graph start and stop at the same spot? Yes. Are they all on the same level? Right? They are in the middle of 0, right? So D is both 0. They both start at 0. That means my C is going to be 0. And the only difference here is my A value. My A value here is 1, but my A value for my blue graph is 3. It's 3 times as large. And if you guys are into music, into mixing songs or something, you realize that this vertical change is volume. Stop yelling at me, Mr. Cole. Stop yelling at me. Right? So when I make the amplitude larger, it changes the volume. The beat is still the same. If you guys are into music, the beat is your B value. Bum, 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 bum. That is the same. Bum, 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 bum. That's the same for both graphs. So the beat is the same. Both graphs are starting right at 0. They're both starting at 0. They both end at the same spot. Okay? They're on the same octave. You can even say that's your octave, right? Higher octaves, lower octaves, higher octaves, lower octaves. And Mr. Ko, you need medication. But the amplitude is how loud it is. And this is now kick up the volume. Okay, so let's do a couple more examples here. I'm going to change our D value and then change our C value, okay? So here is our next example. And I'm going to draw you a graph here. So blue graph, y is equal to sine of x, okay? Where this is 2 pi, this is pi, and this is 1 and -1. My a value, as you can see, is at 1. A is equal to 1. Perfect. My b value is 1 also, because I see this 2 pi over 1 is 2 pi. That is my period. So my b value is 1. Now I'm going to change this graph a little bit differently. I'm going to kick this up. 2 and 3. I'm going to draw the graph up here. So let me ask you what has changed. Has the period changed? Are we still starting and stopping in 2 pi? Yeah. So my red graph, my b value is still 1. How about my a value? Is the amplitude still up 1 and down 1? Take a look. Up 1, down 1. That looks like 1, up 1, down 1. A value is still 1. My C value is 0 because we both started off the race at 0. But look at my D value. Where is the center of the red graph? Is it 1, 2, or 3? Look at that. Where's the center of my red graph. The center is at 2, isn't it? It's not at 1. It's not at 3. The center is at 2. So my D is equal to 2 because we raised our graph by 2 floors. We still have our highs and lows, but it happens now at 2. This graph is y is equal to sine 1 sine of 1x plus no c's, and then plus d is 2. Or y is equal to sine of x plus 2. It's the same graph as sine, except everything is just 2 levels higher. I raised the octave. Okay, so that's how our D affects the graph. We talked about A, we talked about D. Let's talk about B now. B is a tricky, it is the second most trickiest value here. And sorry, this was called vertical shift, if you need to label it. And our last one is going to be our period. I'm going to say, darn it, period slash frequency. Because period and frequency are not the same, but they're very related. The word period and frequency are related, but they are not the same, okay? But they're very similar. And I'm going to use this example of your doctor. So the period is how long something is. I can't even spell. How long. And frequency is how often. Okay? Period is how long. Frequency is how often. So let's use this example. You go to the doctor and the doctor prescribes you medication. So you go to the pharmacist, and the pharmacist then gives you a bunch of pills, and by law the pharmacist needs to explain to you these pills. So they'll say, wait here while the pharmacist comes and explains you your medication. So you wait there patiently, and they tell you, take 2 pills a day. Take 2 pills a day. Would that be how long or how often? Take 2 pills a day.
Would that be frequency?
That's
That'd be
frequency.
often.
You're right. It is frequency because it's how often, right? Take it twice.
Twice a day, yeah.
Twice a day. So if I write twice, oh, that's twice, haha, 2 times per day. I'm going to rewrite this in a different way to make it easier to look at. It's actually 2 times per 24 hours, isn't it? So your grandma comes home and says, hey, they say twice a day. Can I take it before breakfast and after breakfast? And you're like, Grandma, no. Your dad says, I'm going to take these all at once. He said, twice a day? All right, I'll take it 2 times right now. And you're like, no, that's not right. So oftentimes pharmacists will switch it, and you have to ask them, twice a day, what does that mean? And they'll say, okay, take it, and you'll read the label of things, and they'll say, take it every so many hours. In this case, if I want to take it and evenly spread apart, I need to take this every 12 hours. And that's our period. Because twice a day was really 2 times every 24 hours, which is 12 hours every period. For one period, 12 hours per period. Now, how do you come up with that? Now, it really is the flipped answer. Look, 2 over 24, the flipped would be 12 over 1, or 24 over 2. So here's what we're talking about. If I give you a graph that says, hey, I want to see a sine graph, it's once every 2 pi. A sine graph finishes once every 2 pi. That's 1. That's when our b value is equal to 1. But what if I tell you the b value is equal to 2? I want you to finish, remember this is frequency, finish 2 times every 2 pi. So don't you have to squeeze 2 graphs in here now? But how long would it take you to do each graph? If it takes me 2 pi to finish 2, how long would it take me to just finish 1? just pi.
1 plus.
And here's how b works, or the p works. The period is equal to 2 pi over b. We said b was 2, right? Because I want to see it twice. 2 pi over 2 is pi. And it tells me, hey, finish this by pi. So when it comes to you talking to your grandma, your parents, or little kids, it's easier, instead of saying take it twice a day, you tell them how long to take it in between doses. So that's called a period. It's easier for me to say, hey, instead of just squeeze 2 graphs, imagine if I told you squeeze 3 graphs here. Squeeze 3, if b was equal to 3, you're like, here's 2 pi. Good luck, 1, 2, man, I ran out of space. Let's do this again. 1, 2, man, I ran out of space. I only have 2 there. 1, 2, 3. Oh, that looks a little terrible. So what happens is, instead, let me make this easier for you. If I say p is equal to 2 pi over 3, the time it takes me to finish one graph is 2 pi over 3. Okay, that seems a little confusing-ish. But if I break this into thirds, right, see, into thirds, break each pi into thirds, this is 1 graph, this is 2 graphs, and this is now 3 graphs. It's easier for me to break up. And since I'm going to do my half, half, and half, 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 and half, 0, let me use a different color, 0, up, 0, down, 0. Half, half, and half, 0, up, 0, down, 0. Half, half, and half, 0, up, 0, down, 0. And I have my graph nicely paced out to get 3 of these in. Beautifuler. So the trick is that we are going to use period, not frequency, because frequency doesn't tell you where to stop the graph. Okay, frequency just tells you how many times, and that doesn't help us graph. I'd rather just you tell me when to stop. And this tells us to stop at 2 pi over 3. And another way of graphing this, if you're asked to freely graph this graph, this is what you do. See this? Good job. That's it. Half, half, and half. What's half, half, and half? Half of 2 pi over 3 is 2 pi over 6. The way you cut something in half is you multiply the bottom by 2. And you might not have known this trick, but that's the trick. If I want to cut 4 in half, just multiply the bottom by 2. If I want to cut 100 in half, just multiply the bottom by 2. Just multiply the bottom by 2. We can reduce that, pi over 3.
Multiply or divide?
You multiply the denominator. You're actually multiplying by, by 1/2, which means multiply the bottom by 2.
Ah, I see. Okay.
Right? If I say 100, half of that, you're just multiplying the bottom by 2.
Multiply by 1/2. Okay.
It makes it really easy, actually. Because look at this. You might say, Mr. Ko, I don't like fractions. I don't care. If I want to cut this in half, 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 and half, what do you think that tick mark is if I just multiply the bottom by 2? Pi over 6. It's that simple if you remember the rule. If I want to cut something in half, just multiply the bottom by 2. Pi over 3 times 1/2 is pi over 6. Okay, half, half, and half. Remember we talked about half, half, and half? I still need one more tick mark here. We did half, half, and we need one more half here. And here was the trick. Start counting. This is pi over 6. This is 2 pi over 6. This is 3 pi over 6. If you can count 1, 2, 3, you can do the tick marks. No joke. And 3 pi over 6 can be reduced to pi over 2. Oh my gosh, how would we ever have known that? You don't have to. You can just walk it up. This is 3 pi over 6, because each of these are 1, 6, 2, 6, 3, 6. And you can reduce that. And we have our spacing for our graph now. 0, up, 0, down, 0. And that's how we incorporate our b value into our graphs. So we talked about A, we talked about D, and now we just talked about C. What if I see a graph and the graph looks like this? 1, negative 1. Okay, what do you think the amplitude is going to be, right? Is it going to be 3? Is it going to be negative 8? Come on, it's just 1 up and 1 down. That means my A value is equal to 1. What if I told you I end up at pi over 2? So how long did it take me to finish the graph, starting to ending? My p-value is equal to pi over 2, right? But pi over 2 is not a b-value. No. So what we have to do is we have to rewrite our equation. P is equal to 2 pi over b, right? What do you think b had to be to get rid of the 2 and leave me a 2 behind? You guys do this in your head if you want. And if you don't want to do it in your head, let me show you the math behind it. Pi over 2 equals to 2 pi over b. You can cross multiply. B pi equals to 4 pi. Solving for b, divide by pi to both sides. B is equal to 4. It turns out my frequency is 4. Wait, what? How'd you do that? B is equal to 4. Let me, again, this is straight algebra. I'm not thinking about anything special. I said my period is equal to 2 pi over b. That's the situation. That's what it is. How did I know it's 2 pi over 2? That's where my graph stopped. I started at 0. I stopped at pi over 2. That's my p-value. We can cross multiply to get the b on top because I need the b on the numerator. Get rid of the pi's. And we're left with the number 4. That means this graph happens 4 times within 2 pi. Now, I want to show you this as actually true. If this is pi, this is pi, then this is 3 pi over 2, and this is 2 pi. Sorry, I ran out of space. So the graph goes once, 2, 3, 4. I see this 1, 2, 3, 4 times, which is my frequency, which is my b value. C is 0 because we started off at 0. D is 0 because the center is 0, right? It's between 1 and negative 1. This equation is sine of 4x. Y is equal to 1, sine of 4x. Y is equal to just sine of 4x. So we can go backwards by looking at the characteristics and then writing that equation based on what we see. It's very similar, again, back to Algebra 1 and parabolas and Algebra 2 about graphing them and looking at the characteristics, not just plugging in numbers. We're past that. We're above that. We're looking at the characteristics. Okay? So you guys will practice this in IXL. I think you have 3 IXL problems to work on. So that's it.